Hello, I'm Jacob from the Cedar Woods Public Library, and today we're going to be making solar ovens. Solar ovens and/or cookers generally come in one of four types. The first is known as a panel solar cooker. They are known for having a large reflector area that redirects the sun's rays towards a cooking pot. The cooking pot is also generally encased in either a clear plastic bag or a couple of glass bowls in order to form an enclosure to better retain heat. They generally operate at temperatures between 250 and 300 degrees Fahrenheit. Next is what is known as a parabolic solar cooker, which you can think of as a more deliberately angled panel oven. They are basically shiny satellite dishes that are angled to focus on a smaller central point. Due to their hyperfocus, parabolic solar ovens are actually capable of frying food and are capable of getting to temperatures as high as 700 degrees Fahrenheit. So, if you ever wanted to wield the power of the sun to really ruin a steak, this is apparently a decent option. Then, we have the evacuated tube solar oven. Surrounded by the same reflectors as the parabolic oven, in this case, the oven is two layers of blown glass in the shape of a sealed tube, where the air has been removed between the layers. The removal of this air allows for up to 80% of all absorbed sunlight to be converted into heat, allowing this oven to reach temperatures up to 550 degrees Fahrenheit. The final type, and the one we will be using today, is known as a box solar oven. While generally less efficient than some of the other ones we've looked at today, they are hypothetically capable of reaching temperatures as high as 400 degrees Fahrenheit. That being said, in order to get a temperature that high, we would probably have to use wood, plexiglass, and numerous mirrored reflective panels in order to better retain the sun's heat. Instead, we are going to be using the humble pizza box, because it is what I have around, and the last time I tried to actually build something, things went poorly. I suppose you could use a shoebox, provided you're reasonably certain you've aired it out enough. A sun-baked s'more? Delicious. A sun-baked s'more that's been infused with the flavors of fresh polyester? Probably less delicious. Anyway, the first thing we're going to do in constructing our solar oven is to take a pizza box and using a box knife or sharp scissors, cut a flap in the lid of the pizza box. To do that, all you need to do is cut along three sides while making sure to leave about an inch between the sides of the flap and the edges of the lid. From there, we're going to take a measure of plastic wrap approximately 1 inch larger than our flap and tape it to the inside of our pizza box lid. Then we are going to try and gently fold the flap out so that it stands up when the box is closed. Then we are going to measure out another identically sized length of plastic wrap and tape it on the outside of the hole in our pizza box. This plastic window works like a greenhouse roof, allowing direct and reflected sunlight to pass into the box while also retaining the heat. Now it is time to line the inside of our box with aluminum foil so that when we close the box, the entire bottom is covered. Then we are going to do the same to the inner side of the flap. By covering it with aluminum foil, it will hopefully reflect rays from the sun into our solar oven. To do this, we're just going to tightly wrap foil around the flap and then tape it to the back of the box. At the bottom of the box, we are now going to place a black sheet of paper that will act as a heat sink that will absorb direct and reflected sunlight in order to warm our solar oven. Finally, we are going to take a wooden skewer and prop up the solar oven's lid. You'll want to adjust it so it is as close as possible to a 90-degree angle. Now that our simple solar oven is completed, it is time to test it out, which can only mean one thing. It's s'more time. So inside an aluminum dish, we are going to not so carefully set in half a graham cracker, some baby marshmallows, half a chocolate bar, and finally, the other half of our graham cracker. We will throw in an oven thermometer to monitor our temperatures, and then it's time to abandon it to the whims of our cloudless 85-degree day. I leave the solar oven out for a total of about 60 minutes, with the temperature ranging from 160 to 80 degrees Fahrenheit. When I bring the s'more in and look it over, it is immediately clear that the chocolate has had plenty of time to melt, and reveals the baby marshmallows have puffed up and even begun to melt together. And tasting it, I gotta say, not bad. I didn't get to set any marshmallows on fire like I do when I'm camping, but other than that, no complaints. However, as fun as that was, I asked myself, how would our solar oven handle an egg? So, I cracked one onto another container, took it outside, and let it sit in the sun. Over the next 6 hours, the egg doesn't really seem to do much, at least not much that I can see through the plastic wrap. So I let the entire thing go for as long as possible and just kind of hope for the best, making sure to note that our oven temperatures are within the same range as they were for our s'mores. That done, I bring it inside and take a look. As you can see, over the course of its time in the sun, something has happened. The top part of the yolk has solidified, but the majority beneath it is still runny. Then there is the egg white, which seems to have transformed into something akin to clear Elmer's glue, and have, through some egg-based contempt, managed to corrode the aluminum pan it was supposed to be cooking in. Well played, egg. Well played. So, there were the preliminary results of our solar oven. Is it going to be the super breakfast machine I secretly wanted it to be? No. Was it the best solar oven in the world? Absolutely not. It got defeated by an egg. Come on. But it did make a fine s'more. And if the worst I can say about our solar oven is that it is a magical s'more machine, then I would say that is easily time well spent. Thanks for watching.